Hello, my name is Julia Harencar, and I'm in the last year of my PhD at the University of California, Santa Cruz, where I work in Dr. Kathleen Kay's plant evolution lab. And over the course of my studies, I've had the great fortune of working with a lot of really beautiful plant species. During my undergraduate work, I studied rare plant ecology at Mills College. I did a brief stint as a research technician the following summer, studying an invasive species, yellow star thistle, and then went on to do genetic work on both goldfields and eelgrass, which is an underwater plant, at the California Polytechnic State University in San Luis Obispo. All these experiences solidified my love of combining ecology and genetics to understand plant evolution. And this is exactly what I continue doing during my PhD, where I'm investigating the maintenance of species boundaries despite hybridization between two neotropical spiral gingers, more beautiful plants. These two species are found in the same regions in Central and South America, and are capable of hybridizing and create natural hybrids, but they remain distinct and grow in distinct habitats that differ in their light and water availability. Adaptation to these different habitats is critical to the isolation of the species, and my first chapters characterize how the plants are differentially adapted. I first described how one species is capable of withstanding a fairly severe and variable seasonal drought, in contrast to the other, which doesn't deal with drought and can't deal with drought. I then investigated how drought adaptation relates to adaptation to the herbivore environment, finding that differences in investment and trade-offs in investments in defense versus growth and interact with both living and non-living components of the environment to further facilitate habitat isolation between these species. And finally, I use modern genomic techniques to describe the extent of both recent and historical or ancient hybridization between these two species, despite this habitat adaptation. And currently, I'm working on combining my knowledge from ecological investigation of the important differentiating traits with my genomic characterization of patterns of gene flow to better understand how selection on important isolating traits can result in the maintenance of species boundaries, even in the face of hybridization. So I look forward to sharing more details about this work at the poster session, and thank you all for your time.